We're going to be looking at two different types of bisectors in triangles today. One, we're going to be looking at a perpendicular bisector, and the other will be an angle bisector. So remember, bisect means cut in half, so that's kind of what's going on today. For the perpendicular bisector theorem, and remember, if it's a theorem, we can prove it. We're kind of just going to draw a picture and analyze what this theorem says from that. So let's say that we have a segment, and we'll call it AB. And we've got to draw in what the theorem says, a perpendicular bisector. So let's say we draw in a line that's bisecting or cutting AB in half. So kind of draw it so it goes right down the middle. And we can call that maybe line CD. I want to show that line CD is the perpendicular, so that means it needs to make a right angle with my segment AB, so let's mark 90. And I want to show that it's cutting AB in half, so where it hits AB, I want to show that that's in the middle, so I'm going to mark those two pieces congruent. Okay, so I'm going to make a note down here that CD is the perpendicular bisector of segment AB. Now, this theorem says that if you have this situation going on where you've got a line, a segment that's got a perpendicular bisector drawn in, this theorem says that if you take anywhere on the perpendicular bisector, line CD, so maybe we'll take like point C. If you take point C and you connect it to the two endpoints of the original segment, this theorem says that those two pieces have to be congruent. Okay, and it makes sense, you guys, because CD is like smack dab in the middle of AB, right? Because those two pieces were the same. So anywhere on line CD connected to A and connected to B would be congruent. They could have done the same thing and connected D to B and D to A, and those would have been congruent. Okay, so we're going to make one more little note. And we're going to say, like, the result of this picture is that any two segments drawn from line CD to the endpoints of AB are congruent. Ooh, can't see that. There we go. Okay, so like I said, they could have taken anywhere on CD and connected it to A and connected it to B, and they would have been congruent. Okay, for example, they could have gone from D, like I said, to B and D to A, and those would have been congruent. Okay, so this is a lot of just recognizing like where the equal parts are. So there's two examples, problems that you should be able to do off to the right here. And example 1 says find AB, find BC, and find ED. ED should be super easy. It's marked congruent to the piece that's 8. So let's fill that one in first. ED's got to be 8. It's got to be the same. Now, I can tell from the picture that it's exactly like the original one that I drew. AC is the perpendicular bisector of BD. So anywhere on AC connected to B and connected to D, those two pieces are the same. So AD and AB should be the same. So if this guy's 15, AB has to be 15. Okay, same thing down here, you guys. C to D, if that's 18, then C to B, that has to be 18. Okay, so it's a lot of just, like I said, recognizing what's equal. Down here, it's the same idea. So I can tell from the picture, here's the original segment, and I can tell that this WY piece is cutting this segment in half at a right angle. So WY is the perpendicular bisector. Any point on WY, so it looks like they took W, and if you connect it to the original endpoints of the segment, those two are the same. So I'm just going to set 2x equal to 3x minus 5. And then it's just a simple algebra problem. I'm going to subtract 2x. Ooh, that's positive. And then I'm going to add 5 over. And I get x equals 5. Notice that they also wanted you to find TW. So TW is the 2x part. So if I just plug in 5, TW, 2 times 5, 10. Okay, on the back, it's the same idea, except this time we're talking about an angle, not a segment that's being cut in half. So let's get a little visual going. Let's draw a picture here. So we got some angle, and I'm going to call it angle ABC. Okay, we're going to draw a angle bisector in. So let's start at B and just draw something right down the middle. And I'm going to draw it cutting the angle in half, so I need to show that by marking the two pieces congruent. Okay, so let's call that point D out there so we can kind of like label what's going on. All right, so I'm going to say BD, that ray, is the angle bisector of angle ABC. Right down the middle, it's cutting it in half. It's the same idea as the last thing, you guys. Your angle bisector, BD, if you take any point on BD, since it's right in the middle, if you take any point on it and connect it to both rays of your angle, those two pieces are going to be the same. Okay, so they could take like maybe point D, and they could connect it to that ray and to that ray, and those two pieces are the same. Now, the kicker here is that they're always going to make the pieces drawn from the bisector perpendicular to the rays. So you're always going to see right angles. And the reason that that's there is because you need the triangles to be congruent, and that's really what we're looking at is two triangles. And they're congruent because of angle, angle, side. So it's always going to be at a right angle. Otherwise, you could kind of like draw them any which way. So don't let the 90s like throw you off on the picture. You're going to see that. They'll always be there. Okay, the big thing that you need to notice is that the two segments are congruent. So we're going to make a little note here at the bottom of the result. And we're going to say any two segments, and I'm going to say any two perpendicular segments, because like I said, that 90 is always going to be there. Any two perpendicular segments drawn from the angle bisector to the two rays are going to be congruent. Okay, so two problems again. The first one, you look for the angle bisector, so that's going to be CF here. Any point on CF, if they connect that to the two rays of the angle, like they did here and here, those two pieces are going to be the same. So when in doubt, you guys, set things equal, which is exactly what I'm going to do here. And then I just solve for x. So 3x equals 24. And then if I divide by 3, x is 8. Notice again that sometimes they ask you to find more than what is kind of like initially thought to find, not just x. They want to know what's FD, that segment, and what's FB. And they should be the same if we did this right. So we're going to plug in 8. Let's plug it into FB first. So 5 times 8 is 40. And if I plug in 8 to 2x plus 24, 8 times 2 is 16 plus 24, 40. Okay. the next one is the same idea. Again, let's see. I see, if I extend this piece here, this piece is acting as my angle bisector. Ooh, a little glare there. There we go. And I know that because when they took a piece on that pink bisector there, and when they connected it back to the picture in the angle, those two pieces are marked congruent. Same thing here. So I know that this segment here, we'll call it ray HL, is right in the middle of this picture. Okay, so therefore I know it's the angle bisector. So again, I'm just going to set these two pieces equal, 6y and 4y plus 18. All right, then I'm just going to solve for y. And if I divide by 2, I get 9. The problem, they also wanted me to find the measure of angle KHL. So I need to tell them how many degrees KHL is. So first things first, let's find KHL. Let's see, KHL is this piece, which is 6y. So if I just plug in 9, 6 times 9, 54.